Good afternoon, everyone. Hope you're having a fantastic Aquanor so far. I must be honest, it's my first time at Aquanor. I'm pretty blown away, to be honest, with the innovations and the really cool products that I'm seeing out there. I was at a booth earlier where there was a company that uses lasers to detect early sickness in fish. I thought that was really, really, really cool. But my name is Charles Abernethy. I'm the Global Product Manager at Hydrotech. And today I'll be giving you a short presentation on optimizing mechanical filtration in recirculating aquaculture systems, or RAS farms. So in the world of RAS, water quality is everything. A recent study by researchers at the Technical University of Denmark, the DTU Aqua, in collaboration with Hydrotech and Veolia Water Technologies, dove deep into how one critical but often overlooked detail, the mesh size of drum filters, can dramatically influence RAS performance. Before I jump into the paper and its conclusions, allow me to set the stage by providing some background into drum filter technology and their usage in RAS farms. So RAS are closed-loop systems designed to minimize water usage by continuously filtering and recirculating the water. However, organic waste such as feces and uneaten feed can accumulate and degrade water quality, affecting not only fish health, but also the performance of biofilters and the overall operation. This makes mechanical filtration a critical part of RAS design. And while it is only one of the steps within the farming process, if done properly, it can have a significant contribution to fish health, growth, and system longevity. One of the most commonly used mechanical filtration technologies found in RAS farms is the drum filter. Drum filters are a popular choice in RAS because they operate automatically and can handle varying flow rates. They use a rotating drum covered with a mesh screen to trap particles, and a technique called backwashing removes these accumulated solids by spraying water at a high pressure onto the mesh. It knocks the particles off and captures them in a trough for discharge and handling. In this process, the mesh size is crucial, as it determines what particles are retained or pass through. It also has an influence on the amount of water that can flow through the filter for a given TSS, or total suspended solids in the water. Okay, now we've taken a very brief look at how mechanicals fit into a RAS farm. I want to take a look at the study and its conclusions. Firstly, the study began with the problem of suspended solids and system stress in a RAS facility. In RAS, fish waste, uneaten feed, and microbial particles can accumulate very quickly. And if not effectively removed, this particulate organic matter can degrade water quality, reduce oxygen levels, overburden biofilters, and fuel excessive microbial growth. All of this can hamper fish health, growth rates, and overall system efficiency. And to tackle this, many farms use mechanical drum filters to trap suspended solids, but not all filters are equal, especially when it comes to the mesh size. The study setup allowed the team at DTU to compare mesh sizes in real RAS conditions. The study compared 3 drum filter mesh sizes, 70 micron, 45 micron, and 30 micron, plus a control system with no drum filter. Over 8 weeks, identical pilot-scale RAS units were stocked with rainbow trout and monitored for water quality, microbial activity, and for fish performance. The findings? Clearer water and healthier fish. What we discovered was that all drum filters led to significant reductions in suspended particles, turbidity, and organic matter compared to the control group. And this is obvious, and is the reason why some form of mechanical filtration is used on RAS farms all over the world. What is interesting, however, is that the 45 micron mesh filter consistently delivered the best results. We observed particle reduction. The 45 micron mesh achieved the greatest reduction in both particle count and surface area, helping to lower turbidity by over 60%. We observed organic matter removal. It reduced particulate biological oxygen demand, BOD, and chemical oxygen demand, COD, by nearly 50 and 75% respectively. And finally, we observed lower microbial activity. Reduced levels of organic matter led to a drop in microbial activity, making the system easier to manage and potentially reducing the need for chemical disinfection. It should also be noted that the study found that using a 30 micron mesh did not provide additional improvements over the 45 micron, but in fact came with downsides like reduced filtration capacity and more frequent backwashing, which could increase operational costs at the RAS farm. So what do these results mean for aquaculture RAS farms, and why should they optimize their mesh sizes for 45 micron? Well, firstly, and most obviously, to achieve a biomass boost as feed efficiency translates to growth. Perhaps the most compelling outcome was improved feed conversion ratios, or FCR, in the 45 micron mesh group. With better water quality, fish in this group showed a statistically significant improvement in FCR, 0.79, compared to 0.86 in the control, resulting in 8.6% more biomass over the study period with the same amount of feed. Secondly, using a 45 micron mesh size also had a significant benefit on the operational efficiency of the site. The study found that this mesh size resulted in the best water quality parameters in terms of BOD, nitrogen, and phosphorus, which equated to healthier fish and less frequent backwashing. An important factor, as this lowers the energy consumption of the filter and in turn the energy demands of the overall facility. So what can we conclude from these results? Well, according to the research findings, we can safely say that optimizing mesh size to 45 micron mesh pays off. The study highlights that drum filter mesh size isn't just a technical detail, it's a key performance driver in RAS operations, specifically for greater biomass production, for enhanced water quality, and for operational profitability. For RAS operators aiming to maximize fish health, system stability, and economic returns, the message is clear. Optimize your filtration, starting with the mesh size. And while the study only looked at drum filters, there is an alternative mechanical filtration technology used in RAS farms, and that is the disc filter. A disc filter is a mechanical filter that uses multiple rotating discs covered in a fine mesh to remove suspended solids from the water. Compared to a drum filter, it offers 2 to 3 times more filtration area and uses less backwash water and less energy. For those of you who visited the Hydrotech booth during the past couple of days, you will know that we recently launched a brand new product, specifically catered for the aquaculture and the RAS industry. We call it the hybrid filter, and it's a combination of the best elements from drum and disc filter technologies, namely the higher hydraulic flow capacity from drum filters and the larger filtration area from disc filters. By including a hybrid disc filter within our portfolio, Hydrotech can offer customers a broader filtration offering. And with having 2 different solutions, it's worth asking the question of when is this hybrid disc filter more suitable versus the drum filter? Well, the Hydrotech hybrid disc filter is a perfect choice when there is an operational need to combine several key sizing and design criteria without significant impact on hydraulic performance. In addition, the Hydrotech hybrid filter has a higher hydraulic flow capacity versus a disc filter with the same footprint, and more than triple the filtration area versus a drum filter with the same footprint. This means that under certain conditions, fewer overall units are needed, reducing the overall filter footprint size on your site. As you can see in the graphic behind me here, by keeping the hydraulic flow and mesh size constant, but changing the filter type, you can have a significant impact on the overall filter footprint size, resulting in major cost savings for farm builders, not only in terms of number of filters, but in terms of civil and concrete works. I want to take a look at a real-world example now that illustrates this quite nicely. Here we have a scenario where we have sized appropriate filter types for a given hydraulic flow and mesh size to achieve comparable outcomes. The most obvious realization is that for this particular site, the customer would need significantly less filters if they chose to go with a hybrid disc filter versus a drum filter. 17 hybrid disc filters versus 25 drum filters, you can see. But what perhaps is less noticeable and worth mentioning is that this isn't always the case, as you can see in departments 7 and 9, where the same number of drum and disc filters would be required. So a key take-home message around this is that with the introduction of the hybrid filter to our product range, farms can access the optimal filtration solution across all departments and applications through installing both drum and hybrid disc filters in the same farming system where they are the best fit. In closing, I just wanted to briefly summarize. So what we learned from the research done by the Danish University of Technology is that the optimum mesh size in a RAS farm is 45 microns. Optimizing for this mesh size results in increased growth performance, improved fish health, and optimal water quality in the RAS facility. And depending on each RAS farm's unique requirements, this 45 micron mesh might best be achieved by a drum filter, a disc filter, or a combination of both. Regardless of the need, Hydrotech has a solution in our portfolio to assist. And if you'd like to learn any more about the hybrid filter which we launched yesterday, or if you have any more questions or want to discuss the presentation that I've just given, please feel free to meet us at booth D363. We'll be there for the rest of the day, today and tomorrow. Thank you very much.
Thank you very much for this nice presentation. Does anyone have any questions? Come on. No? Yeah, there's one question.
Hi.
It's coming a microphone over there.
Okay, I should not scream then.
Okay.
Hello. Well, thank you for the talk and presentation. Really interesting. Just one thought about what do you think is the difference between the 30 and 45 micron mesh size? I mean, did you do water quality measurement, I assume? Like, what were the differences in the water?
Well, the water quality, sorry, I'm back on. The water quality itself obviously had a difference between 45 micron and 30 micron. The 30 micron left through less suspended solids, but the benefits in terms of energy savings and in terms of backwashing amounts, that offset the water quality performance of the 30 micron mesh. And that's why we say that 45 micron is the optimum level, where it balances water quality and as well as backwashing and energy consumption. Because any higher and you let through too bigger particles, and any lower and you're backwashing too much and resulting in too much energy. So 45 micron is kind of the sweet spot, if you will.
Anyone else? We have time for one short question. No? Then I have one. How do you think this 45 microns mesh size would work at a full commercial scale?
How would it work in a full commercial scale?
Yeah.
Well, I mean, we've done small scale testing, but we believe it can be scaled up. The water quality is the same, it's just at a higher flow. And that is why we've designed this hybrid filter, to attain that higher flow capacity. Because if you try and do this 45 micron on a disc filter, you're not going to be able to get that same flow capacity through it. And that's why we specifically designed the hybrid filter to achieve 45 micron filtration size, but at a higher flow capacity.
Thank you. Thank you
you.
for your presentation.